Welcome to lecture number 111 of digital electronics. Here we are starting off with model number 5. So in model number 5, the initial topic is state machines or finite state machines. Before going into finite state machines, let us have a background of sequential circuits. So coming into what is meant by sequential circuits. In sequential circuits, it will travel through different states. That is, for example, if you are having a ring counter, it will travel through 8, 4, 2, 1 and 8. Like that it will travel. Okay, so it has 1, 2, 3, 4 valid states. Okay. Now, that means from 8 to 4, the transition time is 1 clock pulse. Here from 4 to 2, again 1 clock pulse. That means these sequence circuits are changing its state. The change of state of sequence circuits. Sequential circuits is based on clocks. That is based on clock signal. Now, coming to the next question. Here, the valid states through which the sequential circuits passes. This is known as state diagram. Okay. Now, if it is done for self-starting counters or self-starting sequence circuits, there we will include invalid states also. But generally, if you are including the valid states and how it is passing through that valid states in 1 clock pulse, then that diagram is known as state diagram. Now, coming to the next question. What is a finite state machine? Now see, in sequential circuits, what happens? The circuit will pass through, or the sequence circuit will pass through specified states 8, 4, 2, 1. And if it is self-starting, say if it is 0, it can come to 1. If it is 3, it can come to 1. That means that states are not specified, but you can make it into self-starting. Now, what is finite state machines? Finite state machines is a sequence circuit which has finite number of states. Okay, it has finite number of states. That means if you are designing a finite state machine only for 4 states, you are allowed to only play with these 4 states. That is, the number of states is finite or limited. Okay. Then such kind of state machines are known as finite state machines. For examples, if you are having a ring counter, again I am taking the ring counter as an example. There, if you are having only 4 states, then it can be considered as a finite state machine. Whereas if you are going into some other state or infinite number of states, you cannot say that it is a finite state machine. So what is a finite state machine? Finite state machine is basically a sequence circuit itself, but only condition is it contains finite number of states. Now, generally there are 2 types of finite state machines. One is Mealy state machine, and second one is Moore type state machine. So these are the 2 types of state machines. That means here what I am having is, first you will fix the finite number of states, then we will form the state machine. Okay, the state machine is actually a sequential circuit itself. Now coming into Mealy state machine. So here in many state machine as well as more state machine, the specialty is that it contains memory elements. Now, if I am drawing a many state model, state machine, it will be like this. You are having inputs, combination circuit, some combination circuit is there. If some inputs are given to combination circuits, it will produce outputs. And there is a memory part in that. Here there is a memory. Okay, that gives a sequential part. So generally any state machine is a combination of combination circuit and memory part. Now, what does memory do? The purpose of memory is it provides some and past of it provides some and part of previous inputs, part of previous outputs, previous outputs and present states as inputs. That means previous outputs and present states is given as input. That means here for many state machine, output is a function of present input. Output is a function of present input and present states. Okay. That means here present input means this and present states means state of the memory. That means state of the sequence circuit. So this is basically a combination circuit and this one is basically a sequential circuit. Now, here again, in a sequence circuit or state machines, what's on clock signal? It was on clock signal. So, here what you can say, if you are going for a positive transition, gate signal, generally, then the outputs are only valid for positive transitions. Whereas if you are going for negative transitions, then output is only valid for that negative transitions. Then the output is only valid for negative clock or negative transitions. Okay. So that is regarding the clock signal. Now, generally what is a Mealy machine? Coming back to Mealy machine, generally what is a Mealy machine or a state machine? In state machine, you will have a combination circuit and memory. And if output is a function of present input and present states, then such kind of state machines are known as Mealy machines. So the block diagram of a Mealy machine is shown here. Now, what is the function of memory? The function of memory is to provide some and previous outputs and present input. Okay, if you are providing back the previous output, it means you will have memory. Okay. Now, also it is providing back the present states as input. Okay. So that is basically a Mealy machine. Now coming into the state diagram of a Mealy machine. State diagram of a general Mealy machine. State diagram of a Mealy state machine. Mealy state machine. Okay. So here I am going to take 3 states, finite number of states. So I am taking A, B, C. These are the states. Okay. Now these states are represented by circles. So we are having A, B, and C. The states are represented by circles, and each circle there is only one state. Now, here on the application of clock pulse, you need to jump from one state to other state or remain in the present state itself. That is only provision. So, generally here what you are doing is you are having some representations as input bar output. Okay. That is, Suppose if I am writing from A to B, it is 1 bar 0. That means when the state is A and the input is 1, the output is 0. And if that is the case, it will jump from A to state B. Whereas again here here I am showing jumping from A to A. That means here input is 1. So here I am taking input as 0 and output also as 0. That means if A is 0 and if state is A, input is 0, then it will jump back to A with the output as 0. Okay, so I can make it in that way. Again, B also I should have what? One input. So here I am having 0 bar 0, 0 bar 0, and here what happens? The input should be 1, 1 bar 0, or 1 bar 1, whatever we can have. Okay. Now, at C, if I need to come back to B, I can make it as 1 bar 1. What does that mean? If C is the state and input is 1, the output is 1, and it will jump to the state B. Now again, if it is coming to the state A directly from C, I can give it as 0 bar 0. That is as per my wish. Here when 0 is the here C is the state. If C is the state and 0 is the input, then my output is 0 and it will come back to A. So this is basically a state machine. Okay. So this 1 bar 0 means input is 1 and output is 0. Okay, that is here what is A? A, B and C are defined in memory. A, B and C are the states which is states of the memory. Then what is the input? Input is here. Here I am giving the input. Then what is the corresponding output? That is shown. Okay. Right? Okay. So this is the input and this is the output. Okay, that is shown here. Okay. Now I will show how to draw the state diagram and state table from the Meili state machine. So for example, I am taking 4 states. Say A, B state is there, C state is there, D state is there. Okay. A, let the state be 0 0. This is 0 1, 1 0 and 1 1. Okay. Now in that case, I am given the input as 0. First case is jumping to it. Input is 0. Then output also can be 0. That means the output of the state machine can be 0. But it will remain in state A. Again, here what happens? It will toggle from A to B if input is 1, but output is remaining as 0 itself. Again here, I can make it like this. That means input is 0 and output is 1. It will remain in B itself. Now coming into B to C. Here what happens? 1 bar 0. What does that mean? If input is 1 and state is B, the output is 0 and it will go to state C. Okay. Now what is coming to the next state? Here what will have is from C I should have what? I should have 2 inputs. Either it is 1. Then output is 1. Okay. Then here I will go from C to D. I will get it as 0 bar 0. Okay. Here also I can take it as 0 bar 0. That means here when D is the state, input is 0, output is 0. Okay. From D to A, this is going back. Again, I can write it as 1 bar 1. Okay. So this is the general state diagram of a Moore model. Of a Meili model. Of a Meili model. For Meili state machine. Okay. Now let us discuss about what is this state table of this. What is the state table? Okay. So here I am having present state, that is PS. Present state I am writing. Then I am writing next state and the corresponding output. Okay. Now this next state and the corresponding output. Okay. Now for what input? That is the question. For what input? Okay. So I can have two types of input. Input can be, say I am taking the input as H. So I can make, I will rewrite. Nested comma output for which input? Input is H. So for which kind of input? Input I can make it as H is equal to 0 or H is equal to 1. So present state can be A, B, C or D. A, B, C, D. If state is A and input is 0, what is the condition? Input is 0, that is this condition. If input is 0, my output is 0, but next state is coming to A. So it is, next state is A itself and output is also remaining as 0. Now coming to H is equal to 1. Now my present state is A and my input is 1. Then what is my next state? Next state is B. In that case, what is output? Output is 0. Right. Now coming to node B. In the case of B, state B, if H is equal to 0, that is input is equal to 0, my output is 1. Sorry, okay, yeah. When my input is 0, my output is 1. So I can write. But here what is the case? Here my input is 0, H is equal to 0, but my output is 1, and it is coming back to the previous state. So that means next state is B with output 1. When state is B and H is equal to 1, what is my output? Output is 0. That means if that is the case, that means that is a transfer from B to C. So next state is C with output 0. Next state is C. Yeah. Next state is C with output 0. Now coming into C. If C is the case and if input is 0, you are going into D. If input is 0, you are going into D. But what is the output? Output is 0. So you can write it as D comma 0. Now here what happens? When my state is C, my input is 1. It is coming back to C with output 1. So it is C comma 1. Now coming into D. When input is 0, my output is 0, and it is coming back to D. So it is D, my output is 0. Again, when H is equal to 1, my output is 1, but it is going to the state A. So A comma 1. So this is the state table. This is the state table of Melee model. Okay. Now, so you got some concept about this Melee machine. Okay. So in Melee machine, what you are having input, output, and states. Okay. So here initially I am defining the states A, B, and C, and depending on what is the input, the output is being generated. Now coming into more state machine. Okay. Coming into more type state machine. Here what is the difference? Here the output is a function of only present states. Output is a function of only present states. Okay. That is, if you are drawing the block diagram for more state machine, you are having a combinational logic. Here you are having combinational logic. Then what you are having is memory. So here input is there. Now this is the memory part. Coming back to the combinational circuit. But output is taken from the memory. That is why we are saying that output is a function of present state. So state is in memory. Okay. Whereas input is in the combinational circuit. Okay. So that is the general block diagram of a more state machine. Again, here what happens? The output is valid. Here the output is valid only after transition of state. only after a clock pulse. Only after a clock pulse. That is transition of state. That is transition of state. Of state. Okay. So that is a general block diagram of Moore state machine. Now, let me show how a general. Let me draw the state diagram of a Moore state machine. State diagram of Moore state machine. Okay. Suppose we are having states. So here what is represented is states along with respective outputs is labeled along with respective outputs. That means it is like states bar output. Okay. That is labeled in each state. That is, say for example, if I am having state A, my output is 0. B, my output is, I am taking it as 0. For C, output is 0. And for D, my output is 1. For D, my output is 1. I am taking like that. Now, here what happens? When input is 0, it will come back to A itself. Here when input is 1, it will go to B. Here again, now here when input is 0, it will go to C. Now here when input is 1, it will come back to here itself. I am giving an example. If it is, we can write any number, no problem. That is 1. Here I am giving it as 0. Okay. Now here when it is 1, there is a chance. Here when it is 1, it will go to state B. If it is 1, it will go to state B, and if it is 0, it will go to C. And at C, when it is 1, it will go to D, and when input is 0, it will go to A. Input is 0, it will go to A. So this is a classical example of a Moore state machine. So here what I am having is on the nodes or on the states you are having the output rows, and inputs are given as transitions. Okay. So drawing another state machine, I am having example of Moore state machine. Example of Moore state machine. Okay. So I am having 4 states. For example, A, B, C, D. So this is 0, 0. C I am taking it as 1. D I am making it as 0. Okay. If the input is 0, it will remain in A itself, and if the input is 1, it will go to B. Here, if the input is 0, it will remain in B itself, and if it is 1, it will go to C. Again, here if it is 1, it will remain in C itself, and if it is 0, it will go to D. Here, 1 means it will remain in D itself, and if it is 0, it will go to A. Okay. So this is state machine. Now let me draw the state table. Let me draw the state table. Okay. So here I am having a present state. Present state is there. Now, what is next state? Next state is depending on the input x. Input x. So there I am having x is equal to 0 and x is equal to 1. Then what is the output? That is the question. So present state I can have A, B, C and D. A, B, C and D. And at A, when input is 0, it will remain in, when input is 0, it will remain in A itself. Okay. Now, if input is 1, it will go to B. When present state is A, what is output? Output is 0. Now here B, what is the output? Output is 0. Now at 0, that means when at C, that is when the input is 0, it will remain in B itself. If input is 1, it will go to C. Now for C, what is the output? Output is 1. Then for C, when input is 0, it will go to D, and input is 1, it will remain in C itself. In the case of D, what happens? The output is 0. Now when input is 0, what happens? When the input is 0, it will go to A. When input is 1, it will remain in D itself. Okay, so that is a state table of more state machine. Now, if you are drawing some example of a logic circuit of Milli model, okay, a logic circuit, okay, of Milli model. This is an example one. Okay, we will have flip-flops, say D1, Y1 bar. Here I am having output. Okay. Again D2 I am having D2, Y2 or Q2 bar. Okay. Now here my input, here it is coming from Y bar. Y bar is going in here. Then what is coming in here? X. So X is the input to D1. That X is going in here and here. Here X is going in there, and X is also going in here. Yeah. Going in here. Okay. Then I am making this as D2. Okay. Now what is coming here? Oh, this one mistake. Okay. So it is the input to D flip-flop number 1, and here I am having an AND gate. Okay. So what I am doing is, okay, H is taken and Y1 is also taken. Y1 is also taken, and that is given as D2. Here Y2 is taken out. So this is Y2. So Y1 and Y2 are taken out. Now here if I need to AND Y2 and Y1, you will get Y2, Y1. Then so I am taking H also and barring it. Okay. And taking the sum of these two. So here my output, say T is equal to, I will get H bar or Y2, Y1. So here what happened? Here the output is depending on the input. Here T, that is the output T, output T or Y. Output T is depending on input and states. Okay. And such kind of model is known as Milli model. Now coming into logic circuit of Moore model. So let it be. So I am giving an example. I am not going to the analysis of that. So I am having T1, Q1 bar, T2, Q2 bar. Okay. So here I am having output Y. Okay. Input is X. X is given as input here to T1. So here I am taking from Q2. So some clock is there. Okay, clock is common. Here I have forgot to mention the clock. Clock is common. Yeah. Now coming into this one, I1 bar. Okay, so Q1 bar I am taking, and Q2 I am taking. Okay, so that is Y. So Y is basically what? Y is basically I am taking it as Q1 bar Q2. So here is Y is only a function of present states. Y is only a function of present states. Okay, or even okay, it is a function of present states. That means it is not depending on the input. Okay, so such kind of models are known as Moore models. Okay, so that is the specialty of Moore models. In Moore state machine, the states in Moore state machine, the states along with the respective outputs are there. Whereas in the case of that means here Moore state machine, the output is only a function of present states. Whereas in Mealy machine, in the case of Mealy machine, output is a function of present input and present states. So that is the basic difference between Mealy machine and Moore machine. Now coming into a comparison of Mealy machine and Moore machine. Comparison of Mealy machine and Moore machine and Moore machine. How will it be? Okay. So here I am having Moore machine. This is Mealy machine. Okay. So what is the first difference? Here output is a function of present state only. Present state only. Whereas in Mealy, what happens? Output is a function of present input and present state. So function of present input and present state. Second one. Now here in Moore machine, output is a function of present state only. That means if the input changes, it will not affect the output. So input changes in input. Okay, or input changes. Input changes does not affect output. Does not affect output. Whereas here what happens? Input changes will affect output. Affect output. Now coming to the third and last difference. Here more number of states are required for implementing a function. For implementing a function. Whereas here compared to Moore machine, less number of states are required to implement a function. So that is the basic difference between Moore and Mealy machines. So in this lecture we have introduced about what is meant by Moore machine, what is a Moore machine, or generally I will explain from the first. Okay. So we have started with what is a frequency circuit, okay, and what is a finite state machine. Finite state machine means it can count or it can pass through finite number of states. Okay. So in this lecture what we have explained is what is finite state machine. So it can pass through finite number of states. Then after that what we have explained, we have done with a logic circuit of FSM, that is Moore state machine and Mealy state machine, and we have brought two examples of finite state machines. Thank you.